to go into the details of finding the x-intercepts. I hope to find your x-intercept, okay, you can use your calculator, but the most common method is the non-calculator method, where is the vector theorem. So if you go to your advanced calculator, it has got the equation option, then the fourth one on my calculator, that's the cubic equation. So that's number 4. If I want to get the x-intercept, okay, of the equation which I gave you yesterday. Can you stop whatever you're doing, please? Let's go over the homework. Can you stop everything? So the question which I gave you, I took it from this book. Some of you, I think I gave you the book. Okay. Some of you already have it. Okay, so the equation is g of x equal to minus 2x cubed minus 3x squared plus 12x plus 20. If the question does not ask you to determine the x-intercepts first, okay, they ask you to sketch, then you can use your calculator. But if the question asks you to determine the x-intercepts, then you go via the vector theorem, the manual way. But your calculators, they can solve a cubic equation for you, okay, as I just showed you there. So your A is -2, your B is -3, C is 12, okay, that's positive 12. Right? And then D is positive 20. Then you press equals. So the first value, x equal to 5/2, that's the one which is here. Okay, so you've got an x-intercept here. Then the second one, okay, if you press equals, it says x2 equal to -2. Sorry girls, can we have one lesson? Can we have one lesson? Okay? Don't multitask. So x2 is -2. If you press again, it says x3 is equal to -2. So you get the same value twice. The moment you get the same x-intercept twice, that should be a clue to you that one of the turning points is going to be on the x-axis. Okay? If you get an x value twice as your x-intercept, it indicates that one of the turning points is going to be on the x-axis. Okay? So this value here, okay, it's an x value, which is an x-intercept, also the x value at the turning point. Then you find your first derivative, which is quadratic. So g prime of x is going to be minus 6x squared minus 6x plus 12. If you want to solve for that, you can also use your calculator. Okay, if the person says sketch, but if the person says determine the coordinates of the stationary points, then you need to do it the manual way. Okay, you solve your quadratic equation. Find your derivative, equate it to 0. Normally there's a mark for finding the derivative and another mark for equating the derivative to 0, or you can combine the two. Right? Your calculator, this advanced one, it has got an option for quadratic equations. So there, -6 is my A, then -6 is also my B, and then 12 is my C. So you get your x1 equal to 1. Which one is this? x1 equal to 1. Did I find my derivative correctly there? Yeah, but it's correct. Right?
Yes, because you can just divide the whole thing by -6.
Okay, so you've got -2, so the other one is, okay, let me check my equation. Did I put it properly? It's 12 plus 20, that's fine?
Yes, so right.
Okay, so it's this point here. Right? X is equal to 1. Okay, x is equal to what? 1 here. Then you substitute the value of x equal to 1 into the original equation, which is g of x. you determine the y value there. Okay? Of which my computer can tell me what that y value is. Fortunately, that y value is going to be 27. Okay? So x is 1 here and y is 27. Okay, let me use a different color to just distinguish them. Okay, so x is 1 and y is 27 at that point. Then when x is 2, so minus 2, it's here at the x-intercept. So this point here, it's a common point for both our x-intercept and one of the turning points. Okay? So your graph starts as concave down, and this we say, when it's showing concave up, it means the graph is happy. By the way, concave up, it means the graph is happy. You can add that. If the graph is happy, then it's concave up. If it's concave up, it means the second derivative must be greater than 0. Okay? Then the graph here, okay, our point of inflection. Okay, let me ask the computer to tell us. Yes?
Why when we mention the point of inflection, we never say it's inflection? We never say it's equal to 0. It's always
Okay. Right here, I'm talking about concave up and concave down. Right? At the point of inflection, the second derivative is 0. So when the graph is concave down, the graph is unhappy, so it's very sad. Okay? When it's concave down, it's like when you are down, you are sad, isn't it? Right? So the second, I'll come to your question. Second derivative is going to be what? Negative, because the graph is unhappy, it's sad. So here, the graph is happy, the second derivative is positive. I'm saying this to help you to remember it. Okay? Second derivative, if the graph is happy, it means the second derivative is positive. If the graph is sad, the second derivative is what? Negative. Are you following that? Yes. Right? So this is a very common question which is asked in examination. If you do a lot of practice, they'll ask you, determine the values of x for which the graph is concave up or concave what? Down. Okay, you need to know what the question is talking about. So, right, so we can find that, okay, our second derivative, I can easily get it. So g prime of x is going to be minus 12x minus 6. So if I equate that to 0, I'll get my, right, let me just rush quickly to it. So that will be minus a what? A half. So when x is minus a half, we have our point of what? Inflection. Our point of inflection, we got minus a half. Fortunately, I've got my grid nicely. So that's the point of what? Of inflection. So here, you have to find the y value, by the way. Did you calculate it?
Yes, sir.
What's the y value?
That's
So we have got minus a half. So we have minus a half and 13 what? 25. Like that. So that's our point of inflection. Now, if you want to find the point of inflection, the x value, find the second derivative, equate it to what? To 0. Solve for x. It's very easy. Right? Your second derivative is always linear, as you can see there. It's always what? Linear. The second derivative of a cubic function is linear. The first derivative of a cubic function is quadratic. Okay? Then, so we have got that. So now we want to know for what values of x is the graph concave what? Up. It's very simple. Once you know this point here, you look to your left. Is there a minimum turning point? If there's a minimum, the graph is happy. So you just say, okay, this is x equal to minus a half. To the left, which means x must be less than minus a half. The graph is concave what? Down. Sorry, concave up. Yes?
I have a question. Why are we saying it's equal to?
Where?
You say x.
That's the point of inflection.
Yeah.
At the point of inflection, the second derivative is equal to 0. At the point of inflection. Because This is the point where the concavity changes from concave up to concave what? Down, or vice versa, depending on the shape of the graph. So the second derivative is not zero at any point. No, it's only zero here at the point of inflection where the graph will start to change its concavity. To the left or to the right of the point of inflection, the second derivative is not zero. Am I answering you then? Huh? Huh? Okay, so to the right of this point, as you can see, there's a maximum what? Turning point. Can you look please? To the right of the point of inflection, there's a maximum what? Turning point. The graph is what? Unhappy. Right? So our answer there, if it's concave down, it's going to be concave down when the values are greater than what? -0.5. Okay? If you don't want to do it that way, okay, let me show you another way. So what you do, if it's concave down, okay? Remember, down means the graph is set. Okay? So your second derivative must be negative. We got this second derivative as -12x minus 6. So you just replace the f double prime of x by what? The linear function. Okay? The linear function is the second derivative. Then you get -12x is less than 6. You divide by a -12. If you divide by a negative number, what happens when you're dealing with an inequality? The sign what? Changes. So you get x is greater than minus what? A half. Which is what I have here. X is greater than what? Minus a half. Then, if it's concave up, then the second derivative is happy. Or rather, we can say the graph is what? Happy. Alright, there's a minimum turning point, so this means the second derivative is going to be positive. We substitute the second derivative. You get -12x is greater than positive 6. You divide both sides by that, you get x is less than -0.5. This is what I got here. Yeah. Okay. So it's pretty straightforward. Only at the point of inflection is where the second derivative is 0. To the right or to the left, depending on the maximum and minimum turning point, the second derivative can be positive or it can be negative. Right? Any question there? Any question? All right. Now, another common question is now decreasing functions. You have done increasing and decreasing functions before, right? What was the definition from what you have learned so far? Huh? What was the definition? Huh? What was the definition? All right. Can you tell me what was the definition?
Decreasing functions have negative.
But that's a calculus definition.
It's when it's going down. Decreasing, it's going down.
That's a calculus definition. What is an algebraic one?
It's when the graph goes down.
That's the algebraic definition. Hey, can I have your attention? Can I have your attention? All right. So far, grade 10 and grade 11, you were taught that if a function is decreasing, it means the y values are decreasing. Right? If the function is increasing, the y values are what? Are increasing. Remember, to determine whether the function is increasing or decreasing, it depends on the y values. You remember that? Because x is always increasing. X doesn't decrease. X has to what? Increase all the time. It's y which decreases. So if y decreases, then the function is decreasing. If y increases, then the function is what? Increasing. But in calculus, The definition is different. If it's decreasing, it is when the first derivative is going to be negative. When it's increasing, the first derivative is going to be positive. Okay? So you may be asked the question, determine the values of x for which the function is increasing or decreasing. Right? So as your class exercise, for what values of x is this function? Okay, let's say increasing. For what values of x is it increasing?
X is between -2 and 1.
-2 and what?
1.
Hey, can you pay attention, please? Pay attention. Right, so this graph, it is increasing from this point all the way up to that point. The y values are increasing. Okay, so I can say the function is increasing when x lies between -2 and what? And 1. Okay? It is decreasing. It is decreasing when x is less than -2 or when x is greater than 1. Please, you must add that on your graph. Add that. It's part of interpretation. Okay? It's part of what? Interpretation. Please add that. It's part of interpretation. Yes.
I think the last one
Which part? Can you please, right, I need to talk about the second question which I gave you. Right, so listen, tomorrow I'm going to talk about equations of tangents, but after the June examination, we'll carry on with calculus. Okay? And I carry on. We still have got quite a lot of things to do, even under interpretation. We still have to find the equation, the two graphs of the first derivative, second derivative, so it's quite long. All right. What else can I ask you here? Okay, I think that's it. For now, we will stop here. All right. If you sketch